This lecture will be looking at exponential and logarithmic equations. So we're looking at how you can solve them, the general types that you will encounter, and the best ways to go about setting them up, and then using the laws and previous methods you have learned to be able to find the answer and normally solve for x. So to begin with exponential equations. So let's say we have a question here. We have 2 to the 2 minus x is equal to 16. So effectively we have to find out what x is, and x is in the power with two terms here. So this can be simple. The way to do this is you want to simplify both sides so that you have the same number, the same integer here. As if you have, let's say, 4x is equal to 2, then straight away you know that x is equal to 2, because the whatever is to the powers have to be equal. So here we have 2 minus x. This is equal to 16, and then 16 is equal to 2 to the power of 4. Therefore we can say that 2 minus x is equal to 4. So that means x, you plus x to one side, minus to the other, x is equal to negative 2. Another example is if it was 4x is equal to 1 on 16. So with this one, you may times 16 over or something like that. However, the easiest way is to recognize that 1 on 16 is when you have a negative exponential, so let's say 2 to the negative x, this is equal to 1 on 2 to the x. So 1 on 16 is equal to 1 on 2 to the 4. And then 1 on 2 to the 4 is equal to 2 to the negative 4. So that means we can get 4x is equal to 2 to the negative 4. Now we can put 4 in terms of 2. So here we have 2 to the 2, so that's 2x. So that's equivalent to 4x. And then that's like 2 to the x. Or you have, sorry, other way around, 2 to the 2x, and then you bring the x down. So this is equal to 2 to the negative 4. 2x is equal to negative 4. So then x is equal to negative 2. So once again, it's the same value. You could have also simplified it quicker with 16 by saying that 16 is equal to 4 squared, and then you'd be able to get that x is equal to negative 2. However, this method also still worked, and that's typical for lots of equations and mathematics in which you may do something that's slightly longer, but you'll still get the right answer as long as every single step you do is correct and follows through the method. Now onto the log function. So even if we have an equation with a log function, it will generally be in the form log AB is equal to C. Now B could be an A and C could be multiple terms, such as, let's say, B could equal x plus 3, etc. But what I'm trying to say is that there are 3 different terms, so A, B, and C, and typically A will just be an integer. So there are 3, if we're trying to solve for x, there could be 3 different places. X could either replace A, B, or C. So to begin with, we'll look at when x is equal to B. So we have log Ax is equal to C, and we need to solve for x. So an example could be log 4x is equal to 5. Now the way you can go about solving this is we firstly want to get but we want to eliminate the log function on this side of the equation, and inevitably it will go on the other side. So the way we can do that is we can put both sides of the equation to the power of 4. So that means we have log 4x is equal to 4 to the power of 5. And then, so what I've done is I've got this equation, and I put them both with 4 to the power of both sides. And that expression still holds because I've done the same thing to both sides of the equation. Now the 4 and the log 4 cancel. That leaves us with x with 4 to the 5. Then using calculator, or if it was a bit simpler doing it by hand, this will then equal 1024. So now we know what x is equal to. So that's the first sort of thing. If x is inside the log, put 4 to the power of the log, and then you can do it like that, and you'll find out what x is equal to. So the other one could be is if x is in the place of c. So we have log a of b is equal to x, and we need to solve for x. So we have, let's say, log 3 of 27 is equal to x. What we do is we just simplify the left-hand side, or the side with the log function in it, and we just simplify for x. So whatever the most simplified form of this equation will be, which in this sense we can bring it down, use some log laws, and we find that x is equal to 3 for this example. However, if you can't get into an integer, just put it down to the most simplified log value you can. So the third is if x is the base. So you have x, b is equal to c. So, an example could be log x 16 is equal to 4. So we want to know that what value x to the 4 is equal to 16, because that's effectively what the log function wants. We have x to the 4 is equal to 16, and we can see that the answer x is going to be 2, because 2 to the power of 4 is equal to 16. Algebraically, from this step though, we can do something else. So we can say that you have log x b is equal to c. We can do what we did before, is we're going to put both sides of the equation up as powers. But instead of having an integer, we're going to put it to log x. So we have log x b is equal to x to the c. And once again, this equation holds. Now the x's cancel out, and we're left with b is equal to xc. Then we can get rid of the c by putting it to the power of 1 on c, each side. These give us 1, because c times 1 on c will give us 1. Therefore, we're left with x is equal to b 1 on c. In this case here, this would have been, let's get some room, but if we had log x 16 is equal to 4, then we take x to both sides, we get 16 is equal to x to the 4, so x is equal to 16, 1 on 4, which is equal to 2, which we've shown before. Now, some of the time with the equations, the previous examples we've just looked at, there's been integers, but Euler's or Euler's number, I'm not 100% sure how you pronounce it, but luckily on the exam it doesn't really matter, is, you've probably seen it before, is e. And just like pi, it's an irrational number. However, it's often used for exponential and logarithmic equations, and you'll see it often replacing the standard rational numbers that we've been using before. So as you remember, like pi is approximate to 3.14, and then it keeps on going. And then e is similar, as e is approximate to 2.718. Just remember that e is approximately 2.7. Then this is, the number comes about because when you have 1 plus 1 on n to the n, when n approaches infinity, so when n gets very, very large, this term here approaches 2.718 ... And then this number here, with the number approaches, is referred to as e. Now, you don't really need to know how it's derived, but just remember it's probably approximate to 2.7, as this is useful in Tech 3, sometimes just to see if your answer's in the sort of the right ballpark. However, you don't need to show how this number comes about. How does it affect the log laws and exponential laws, though? When you have e with the log laws and exponential laws, it doesn't change anything at all. So all the laws still apply, as it's still a number. So you have e to the x times e to the y is just equal to e to the x plus y, for example. Or e to the 0 is equal to 1. Log e squared, you can bring the 2 down, you get log e. Because these are the same numbers, that's equal to 1, so that is just equal to 2. So all the different laws and all the different methods we've used can still apply to e, as just remember, just treat it as a different number. However, it's not as useful as, let's say, 4, as we can put that as 2 squared, and change it around, but rather with e, we just normally have to leave it as e. But you can treat it in terms of the laws as exactly the same as any other number. Just a quick thing with notation though. Sometimes log e to the x is referred to as lx. So that's just a quick thing. Sometimes in your calculator may do that, or in books. However, these are the exact same thing. It's just log to the base e.